After taking up RL and RC, now what we have is 3 elements: resistance, inductance and capacitance. So if you take 3 elements, resistance, inductor and a capacitor, apply a sine wave. Voltage, alternating voltage V is equal to Vm sine omega t. The waveform, input waveform is a sine wave. This is how voltage varies with the time. Issue is the same. You have to find out what? You have to find out current. So resistance R, inductance XL is equal to L omega. Inductive reactance XC was equal to what? 1 by C omega. So step 1, draw diagram. Do it. 3 minutes, 2 pages. 2 pages. Three elements: resistance, inductor and a capacitor, connected in series. You apply a voltage Vm sin omega t, and what you have to find out is current, magnitude of current and phase relationship. Step 1, draw diagram. Step 2, mark voltages, no doubt currents also. Voltage across R is what? VR. Voltage across L, VL. Voltage across capacitor, VC. Mark voltages VR, VL, VC. 1 minute. Applied voltage is V. And in case you want to write a relationship, you can write a relationship also. Total voltage, applied voltage V is equal to what? VR plus VL plus VC. Total voltage V is equal to VR plus VL plus VC. But it is phasor sum, not simple algebraic sum. It is a phasor sum of 3. Write it. Notes बंद कर दो. Step 3, I want to draw a voltage triangle. You can say core of all questions in the chapter, voltage triangle. How many phases are there? How many phases? V, VR, VL, VC and I also. 5. I to be taken as reference. Why? It is same logic we have covered. So I to be taken as reference. I. Mark VR, VL and VC. Mark VR, VL and VC as phasors. Yes, focus only on this part. For a resistance, voltage and current are in phase. So VR is in phase. That means, in case I want to draw it here, if I take this as a reference, I as a reference, then VR is in phase. Second part, inductor. For an inductor, current lags voltage by current. So, voltage VL. Here, VL try third one at your own. VC, try to mark VC. Yes, for a capacitor, current leads the voltage by so VC to be marked here. For convenience, I am taking up a case where inductive voltage is more than capacitive, VL is more than VC. I am taking this case, but in boards or in competition, you may come across a problem where the two are equal or maybe VC greater than VL. We are taking up a case where inductive effect is more than capacitive effect. Now, if VR, VL and VC is you have written, VR is equal to what? I into R. VL is equal to what? I into XL. VC is equal to what? I into XC. These two, VL and VC, yes, they support or oppose each other? Oppose each other. They are 180 out of phase. That is why we can write it like this. VR as it is. This VL minus VC, and the result is V is result or effect of VR, VL and VC. That is why this third side represents voltage V. Complete. If you want to refer this is voltage and this is current. Angle between the two is phi. Completed. Voltage triangle. Step 3 is to draw a voltage triangle. Step 4. Yes. Yes, what is step 4? Standard procedure. Step 4 is to draw impedance triangle. VR is equal to what? Yes. VR, R and I relationship is what? VR is equal to R into I. VR is equal to I into R. VL is equal to what? I into XL. VL is equal to I into XL. VC is equal to I into XC, and overall V is equal to I into Z. What is Z? Impedance. Overall opposition by the total circuit is known as impedance. How do you make impedance triangle if you know the voltage triangle? What to eliminate? Yes, I. Eliminate I from all these, then what you are left with is, if you remove I from this side, what you get is R. If you remove I from this side, what you get is XL minus XC. And if you remove I from this side, what you get is Z. This angle is phi. Z is equal to what? Impedance offered is equal to what? Impedance is equal to R square plus this side square plus this side square, that is XL minus XC square under root is equal to Z is equal to R square. XL is equal to what? L omega minus XC is equal to what? 1 by C omega square. This is what Z equal to. And I am taking into account step number 5 also here. Step number 5, I will write it here. Step 5, phase relationship. Yes, standard. Current lags voltage by what angle? Phi. So current lags, I lags voltage. This wave refers to what? Voltage. Current I, blue color, lags voltage by what angle? Phi. Why it lags? Overall circuit is inductive in nature. If you make capacitance and inductance equal, it becomes resistance. Phi will become 0. If you make capacitive factor more than inductive factor, then current will lead. Time with you is 2 minutes to complete.